I'm a PhD student at UC Santa Cruz. I'm going to be talking about Felt, a simple story sifter today. And so Felt is it's a simple story sifting and rules-based simulation engine. It's written in JavaScript so that you can use it in web browser games. It uses a declarative query language for authoring story sifting patterns, which is one of the sort of major contributions here. Our goal is to make it sort of quick and easy to author large numbers of sifting patterns, even for relatively programming experienced users. Sort of viewing sifting pattern authoring as part of content authoring. You can define simulation actions in terms of sifting patterns. We're going to talk a little bit more about that in a little bit. And there's no mandatory coupling between sort of sifting and simulation. You can just use Felt as a sifting engine or just as a simulation engine. But the project that we're building with it right now sort of use it as both for the most part. It's also a sort of deliberate oversimplification of our approach for the sake of clarity. We're building on this idea of computational caricatures that Adam Smith and Michael Mateus defined back in 2011, of like a system that sort of define the essential parts of what it's doing and the abstractions of what it's doing, and emphasize the core contributions over the generality or whatever that it could in theory embrace. So before I dive into exactly what Felt is and what it's doing, I'm going to talk a little bit sort of some background, the idea of curationist emergent narrative, especially that James Ryan has proposed, and like what story sifting actually means, because I know it's not a familiar term for everyone. Then some related work, some previous events that have made story sifting, some sifting pattern examples we're going to look at. Felt as a simulation engine, some case studies of the games that we're building around Felt, and then future working conclusions briefly. So emergent narrative is one of those things that's been written about extensively. A lot of people have defined it at length. I'm not going to spend a bunch of time on it here. But the idea basically is that this emergent narrative is a genre of generative and interactive narrative experiences and narrative systems that involve a computational simulation of a story world that is it typically features characters running around doing actions, and stories are taken as sort of emerging out of the actions that these characters do. Typically, the simulation doesn't really have any like strong idea of what narrative structure is or like what a story looks like. It's characters doing things, and narrative comes out of that. The player sort of tells themselves a story about what's happening in the game or the play experiences they go through. This has actually produced a lot of great successes for sort of interactive and procedural narrative. Dwarf Fortress and Crusader Kings 2 are typically sort of two simulation-driven, extensively games that are typically treated as interactive narrative or emergent narrative experiences, and players like to tell stories with these. And you can also see that they have typically pretty complex interfaces, and that's for a reason that we'll get to in a second. So it's a good approach for doing this sort of like complicated simulation-driven narrative style. However, it's also got some pains associated with it. And my co-advisor, Michael Mateus, has accused it of being just one damn thing after another, essentially. Things just happen, and there's like all these events happening, and things are going on, and it's not at all clear like where the story is in this. It doesn't have an idea of story structure, so it's not clear like what the narrative part is exactly, except for the thing the player is telling themselves in their head. I would actually reframe this a little bit. I think the problem is not quite that it's just one damn thing after another, but that everything happens just so much. These piles and piles and piles of sort of simulated events that are happening, and at a certain point it becomes overwhelming, right, to the player. Like, how do you possibly navigate this complicated simulation, all these things going on? Most of these events are uninteresting. We don't care about what's going on in most of these. We don't even know who some of these characters even are. It's like totally unclear what you should be focusing on and what you should be telling the story to yourself about that's going on in the system. And so what James has tried to do, James Ryan, in his dissertation, Curating Simulated Story Worlds, is propose this curationist sort of approach to emergent narrative. And this is a sort of conceptual reframing where instead of the emergent narrative being taken as something that comes directly out of the simulated story world, we instead view the emergent narrative as something that is produced by this sort of lengthy chained process of agents sort of operating on the story world and producing artifacts for other agents to consume. And agents here can refer to either humans or computational systems. So you have like a chronicler that takes the simulated story world and looks at, produces a log of the event that happened, and it basically has a chronicle that can be then looked over. Then a story sifter looks at this chronicle and pulls out sort of nuggets of interesting narrative material that can then be turned into a story by a narrativizing agent. And the emergent narrative is the thing that comes out at the end of this narrativizing process, and not things that are happening directly in the simulated story world. The idea here with Felt is that we are mostly looking at the story sifting box. Felt was initially conceived of as a story sifting system. It actually has some tendrils into the chronicler and simulated story world parts a little bit as well, because it grew this sort of simulation engine feature set on the side of it rather naturally. But we're going to talk about that a little bit more later, and you can think of it primarily as a story sifter for the purposes of this talk. And just to recap what story sifting is, we've got all these events that are going on. There's so many of them, we don't know what to care about. So we're going to sort of defocus most of them, and then call into focus using some sort of parameterized pattern, a set of events or a sequence of events that are narratively compelling for some reason. Typically, you're using a sifting pattern that has been defined by the authors of the simulation you're running, and you can sort of pull out these events, look at them in sequence, and sort of look at the pattern that is being used to identify these events as particularly interesting. So here we've got a sequence where there's a character A who starts a project. then decided the project wasn't any good, gives up on it. Then a character B talks to them 3 times about this project, and they finally decide at the end to resume work on this project. So this is sort of like a happy nugget of narrative material that you can throw into maybe a longer story about this character gaining more self-confidence or something like that through the course of their interaction with this character. Now, the thing about sifting patterns, which are these things that are used to specify sort of groups of interrelated events or sequences that make for good, compelling narrative building blocks, is that you really want to have a lot of these if you want to be successful. And the reason for that is that you want to avoid having the same ones come up over and over and over again, basically. And that means that from our perspective, what we really want is to make these sifting patterns as easy to author as possible, especially and including for people who are not necessarily sort of super used to working with these computational narrative approaches, because really authoring sifting patterns is part of content authoring. And we want the writers on our games to be able to author sifting patterns, basically. There's been a bunch of previous story sifting systems. PlaySpecs is probably the closest. This is by Joe Osborne and some other people. And this was sort of an approach that uses this regular expression-like formalism to define sequences of game state changes that you're looking for. And this has been used for narrative analysis in common PlayStation, and also been in best with sort of a co-creative narrative play experience. Bad News is a game by Ed Samuel, James Ryan, and a couple of people that has a team participant who's doing the wizard role, which basically means they're sitting at a Python console that has sort of the state of the story world pulled into it, and manually running some functions to pull out interesting nuggets of information, and send those over manually to the actor who is portraying characters from this world. Dwarf Grandpa is a system by Jacob Garby that has unfortunately not been reported in any papers yet, that looks at Dwarf Fortress worlds and pulls out the stories of certain vampires, basically. And Sheldon is a system by James Ryan that is sort of the most recent of his approaches at story sifting. He talks about this in his dissertation, and I'm going to show an example of a sifting pattern from it later on. And then arguably also The Sims 2 does this sort of thing where it's looking at sequences of events that it thinks are interesting and sort of nudging the simulation to try to complete those incomplete sequences of events. However, there's a lot of problems with sifting patterns as they're currently defined. They're often pretty brittle. They rely on these functions that are defined typically by people who know the simulation pretty well internally. And these functions are hard-coded in such a way that you need to be able to know like the full repertoire of functions that you have at your disposal for navigating the simulated world state. They're often pretty verbose. Variable binding is typically a separate stage from defining what it is you're looking for exactly. They're time-consuming to author, especially if you don't know all the functions that you can use to author these patterns. They can be pretty hard to debug, especially if a pattern is not firing when you think it should be. It's not at all clear why that is usually. And they're also often tied closely to the simulation engine internals, so it's not at all like easy to decouple simulation from sifting. So our main idea, number one, is that we can write sifting patterns in a declarative query language instead of in the procedural languages that we're typically using right now. Declarative query languages are nice because they allow you to specify what you're looking for and not how to find it. This, in this context, means looking for sort of constraints that you're placing on sets of events that you think are interesting narratively. This gives you greater flexibility because it's a compositional language. You can sort of specify additional constraints on your events as you go and be very flexible about sort of what you're actually looking for in a particular query. You get concision out of this because you are sort of defining the variables that you're binding and binding them at the same time as you're declaring what it is you're looking for. Debugging in this process becomes much easier because you can just write arbitrary queries to ask arbitrary questions about your story state on the fly without having to sort of precompose a bunch of these functions that are used to sift into the story state and look around for certain pieces of information. And there's also some weird tricks that you can play if you can do partial evaluation of sifting patterns, which you can if they're declarative. One of these is based on this almost actions approach that Ben Samuel does in Writing Buddy, where instead of just looking at the preconditions for an action and going, we can do this action only if all the preconditions are fulfilled, you can also go, what if almost all of the preconditions are fulfilled? And then sort of provoke the player and go like, hey, there's this thing you could do to make this action possible even though it's not currently. We can do that with sifting patterns, basically. And then there's also this why not function that we've defined that you can call with a sifting pattern that is not firing when you think it should be, and have it sort of procedurally go through and try to eliminate groups of clauses in the query until it finds a group of clauses that is responsible for making it not fire, and then show you the reason that this pattern is not firing right now. So this is a felt sifting pattern example. This is a moderately complicated one. It's got 7 top-level clauses, which are sort of the different things that are defining what's going on in this pattern. The top one here is event sequence. This is the parentheses indicate a rule, which is sort of a way of defining a reusable group of clauses that can also be recursive and refer to itself. So event sequence is a common rule that we use to say these 2 events occurred in order, event A and event B. And anything with a question mark in front of it here is a variable that we're binding, basically, in this query. Then down here we've got sort of property clauses. So event A, for instance, has the event type of betray. It also has an actor who is this character who is assigned to the variable care. Event B is a different event, also event type betray. Also the same character is the perpetrator of that betrayal. And then this character has to have the trait impulsive. And then at the end here we've got this not join thing, which is basically saying that we do not want to see any situations where there is an event in the middle between event A and event B that was also done by the same character. So when you, and this sort of is an awkward way of doing the syntax for this. We have better syntax ideas for how to do this part. This is sort of imported directly from the underlying database and query engine that we're using, that we're building a system on top of. So what we actually have here, like in sum, is we're looking for a sequence of 2 betrayals perpetrated by the same impulsive character, and making sure that this character does not do anything else in between those 2 betrayals. And DataScript is the sort of underlying system that we're using to run the queries and to store the simulation state in the database. It's a JavaScript implementation of datalog, and the language that we've got here basically desugars to a fragment of datalog that is then run in this DataScript query engine. So we can compare this to sifting patterns in Sheldon, which is James Ryan's system for defining story sifting patterns, basically, and running them over the story world. He defines sifting patterns as procedural Python code, and you can see here that we've got a sort of candidate event that we're looking at. It has the name setFire, and we're looking for an ancestor of this event also that has the name hatch revenge scheme, and whose initiator is the same as the initiator of the candidate event we're currently considering, which is a little bit of a roundabout way of saying that we're looking for a sequence of events in which someone committed arson in response to some slight that was perpetrated against them earlier on. And then at the bottom, if we have a match, we do a lot of additional variable bindings, like sort of reaching into the story state and grabbing, like, who was the person who was harmed by this? Were there any witnesses to this event? That sort of thing. The equivalent in felt looks like this, and each of these lines is a separate clause of the query, basically. The top one is saying that we have this arson event that has the event type of setFire, and we say it has the actor arsonist, that there was a contributing cause of this arson event, which is the swear revenge event that happened earlier. The swear revenge event has to be a hatch revenge scheme event, and it has to have the same actor, the arsonist. And then we do additional variable bindings as we go. And the difference here is actually kind of subtle, but if you look at this find ancestor function in particular, you can see that it's got these specific parameters, the name and initiator parameters, and this function had to be defined by someone who knew the simulation state pretty well, who knew how to sort of write a function that could reach into the chain of events that have happened and pull out ancestors that are filtered by specifically the name and initiator parameters. And if you wanted to filter by additional parameters, you'd have to modify this function definition to include additional constraints, additional sort of possibilities for constraints. The difference in felt here is that you can see that we are doing arbitrary constraints on this sort of revenge event because it's just another entity that is showing up in the query. So we can bind it, we can say anything about the properties of it that we want, and you can do this recursively for any number of entities that you mentioned all in a single set, basically. And one interesting thing about this is that this pattern looks a lot like the sort of left-hand side, I think, of actions in things like Chris Martin's Sifter formalism, for instance, where you're binding a bunch of variables and then executing an action based on their values. And so what we can do is we can take these sifting patterns and put them on the left-hand side of an action and use them as action preconditions, basically. So in this context, we're using the exact same sifting pattern as before, but we've also included this additional clause at the bottom that's saying, and also the victim of this revenge sequence harmed some other bystander at some point in the past. And when this happens, the bystander can form some judgments about the situation. They can go, yeah, that revenge victim totally deserved it, they were mean to me in the past. And also that arsonist is a pretty cool guy for taking revenge on someone who hurt me. And this leads pretty naturally into the big idea number 2 here, which is that we can use sifting patterns to implement character subjectivity. So we have this idea of objective reality, which is all of the things that have happened in the simulation so far, all the events. And when I look at this, I might see something like this. So I think these events are super important for whatever reason, and I'm telling myself a story about these events in particular. But when you look at these same events, you might see these events instead. These are the ones that stand out to you. These are the details that sort of stand out in your mind as important. And so when you do this filtering, you see something more like this. And you can see that even though we're matching some of the same events in our sort of descriptions of what's interesting about the story world, it's not at all the same story that we're telling ourselves. We're telling ourselves 2 completely divergent narratives about the same things that have happened objectively. And so what we're interested in doing is allowing characters in our simulated story worlds to perform story sifting as a way of driving their evaluations of the world, of telling themselves stories about the world, basically, and then using that to drive character conflict because they interpret the same events differently. So we have these 2 tiers of character actions that we've got. We've got internal actions, which are sort of rumination or introspection actions, where a character thinks about things that have happened to them in the past, using some narrative framing, which is a story sifting pattern they have access to somehow. And then external actions are things that they do in response to the motivations they formed, the judgments they formed, the evaluations they've made of the world, basically. So internal actions produce motivation tokens based on sort of the narratives players or characters are telling themselves, and external actions consume these motivation tokens to act on the world afterwards, basically. And you can characterize these characters differently by giving access to different sets of story sifting patterns. So a neurotic character might view some events as, oh, this person clearly hates me now, and a confident character might view the exact same set of events as, oh, they clearly need to get to know me better, I'm going to spend more time with them in the future. And you can see some examples of internal and external actions here. The first 2 are interesting to look at on the internal and external columns because you can see that the same events could perpetrate can lead to a character matching the resolve to get revenge on A who keeps doing mean things to B pattern, or also this resolve to be nicer to A who's evidently having a bad day pattern. And then they can either sabotage an experiment or bake a cake to give it to A, based on their sort of evaluations of what A is going through right now, what A is feeling, and their attitude towards this character. So yeah, there's a couple of story construction experiences we're building around this system. Cozy Mystery Construction Kit is one of them, and this is a collaborative storytelling game in which the system is suggesting actions for characters to perform based on these player-defined author goals, which are things like I want to escalate the tension between these two characters, or I want to show that there's a conflict between these two values, and then the current character goals, which are things that characters want to do based on their evaluations of the story world. So they might have intent to sort of form a friendship with another character based on some positive interactions they've had with that character in the past, and therefore they have a certain interpretation of events that's driving their actions. And some other character might have some different interpretation of the exact same actions that is driving them to do some different things. And characters hold these values like loyalty, survival, science, because they're researchers in this setting, progress, friendship, etc., that all sort of interpret or modify which sifting patterns they have access to in making sense of the world, and in so doing allow you to characterize characters in terms of the ways that they're using stories to make sense of the world. And then Diary Town is another sort of play experience that's using fewer of the simulation features of Felt and more of the sifting features specifically. This is taking in these structured diary entries that we're having players produce for the system, which are sort of descriptions of what happened to you today, basically. And the goal that we have here is to use these sifting patterns to run over these diary entries and grab interesting patterns of events that we can then sort of playfully reflect and re-narrativize in this sort of magical realist interpretation of your life. The idea is that this little town simulation that is a model of the people you know, probably the things that you're doing from day to day, and that we can tell these little stories about these characters in this simulated world based on the things that you're putting in your diary entries. And this is also the opportunity that we've had to evaluate Felt so far involved these high school interns who are working with us over the summer on writing content for Diary Town in particular. And for one of the weeks that we had them, we gave them 1 day of training on how to write Felt sifting patterns, basically, and turned them loose for a week, effectively, and didn't really help them much on that. And then they independently authored 85 functioning sifting patterns in a week, which we were pretty impressed by. We think this is a good sign for the usefulness of this approach in terms of making this sifting pattern authoring approachable for content authors who don't necessarily have a ton of programming background. In the future, we would definitely like to evaluate Felt more extensively, and that's in part because we're going to try to continue to develop these case study-like experiences. So Cozy Mystery Construction Kit in particular, we talked about this at PCG Workshop this year. We'll probably talk about it again in the near future, so be looking out for that. We want to extend this domain-specific query language that we're using to define sifting patterns, so the not join syntax that we saw earlier is a little bit awkward. We want to go back to that and sort of come up with sort of better syntax sugar that goes on top of it. And we want to be sure not to overcomplicate it in the process, so we're going to be probably doing a lot of like extensive user testing as we go of like how to make this more effective for the kinds of tasks people find themselves wanting to do. And then we're also trying to further explore this application of story sifting in these two key areas. Number one is this creativity support for story construction play experiences. So like looking at simulations as writing partners and using story sifting to surface like the interesting things that have happened in this story world originally to the player so that they can incorporate them into the stories they're telling themselves, basically, for the stories we're writing for others to consume. And then the other thing we want to do is implement this character subjectivity more and really like sort of hit on this pattern of using these simulation actions to drive these differential interpretations of the same underlying concrete events, so the characters have conflicts and tensions and these different ways of looking at the world and sort of telling themselves stories about what's going on in the world. So yeah, in conclusion, there's a whole bunch of advantages to using this declarative query language sort of style of authoring story sifting patterns over the procedural sort of styles that have prevailed in the past. You can use these sifting patterns in simulation action definitions to diegetically bring story sifting into the story world and have these differential character interpretations of the same events. Felt is the system that we built that is a computational caricature of story sifter, like a deliberate oversimplification that captures the things we really care about in this process, while sort of sidelining the things we don't care about as much. And hopefully that communicates the benefits of our approach somewhat. And Felt is also sort of providing a common sifting architecture for several of these in-process emergent narrative play experiences we're building